How do analog prototype filters simplify IIR filter design? Have you ever wondered how engineers create digital filters that work smoothly and efficiently? Today, we will discuss how analog prototype filters make the design of infinite, impulse response digital filters easier. First, let's understand what an analog prototype filter is. It serves as a stable starting point in the analog domain. This filter is designed to have a normalized cutoff frequency, usually set to 1. By starting with a low-pass analog prototype, engineers can capture the essential frequency response needed for various filter types, like Butterworth, Chebyshev, or elliptic filters. Each of these types has its own unique properties for magnitude and phase response. Once the low-pass analog prototype is ready, engineers apply frequency transformations. These transformations allow them to convert the low-pass filter into other types, such as high-pass, bandpass, or bandstop filters. This means they can adjust the filter's frequency response to meet specific requirements without having to start from scratch. After defining the analog prototype and applying the necessary transformations, the next step is converting it into the digital domain. This is done using discretization methods. One popular method is the bilinear transform. This method takes the poles and zeros from the analog filter and maps them into the digital Z-plane. It also ensures that the filter remains stable and that the frequency response is adjusted for the digital sampling rate. So, why is this process beneficial? First, it allows engineers to use well-known analog filter design techniques. This saves time and effort since they do not have to create digital filters from the ground up. Second, the normalized prototype simplifies the design process. By fixing the cutoff frequency at 1, engineers can handle frequency scaling and transformations in a more straightforward manner. Third, stability and performance can be ensured in the analog domain before moving to the digital realm. This gives designers more confidence in their filters. Finally, the modular approach of designing a prototype, applying transformations, and then discretizing makes the entire workflow clear and manageable. In practice, this method is widely used in electrical engineering for applications like audio signal processing, communications, and control systems. These areas often requiring real-time filtering with low delay. The analog prototype approach helps engineers create efficient and stable infinite, impulse response filters tailored to specific needs. By using reliable mathematical tools and transformations, designers can achieve their goals more effectively. So, the next time you hear about digital filters, remember the important role that analog prototype filters play in simplifying their design.